Good morning. We start with the first plenary session of the morning. And the title of the session is New Issues in Environmental Health. And the first speaker is Donna Mergleler, Professor Emerita by the Faculty of Science at the University of Quebec in Montreal, when she had been a professor in the Department of Biological Sciences from 1960. She headed the Canadian Institute for Health Research between 2008 and 2014, and her team make research on gender, environmental, and health. With her research group, she had developed innovative approaches to examine women's health and proposed new methodologies for studies in occupational and environmental health. Professor Donna Mergleler has authored a large number of papers and has given many lectures around the world on this subject. The title of her presentation is Gender-Based Analysis of Environmental Factors, and she will present us the results of her research and share with us how to promote social and gender considerations when conducting environmental health research. So please, the first speaker. Donna Mergleler, please. You have 25 minutes for your presentation. Thank you.
Thank you very much. It's an honor to be here. I'd like to thank the organizers for a wonderfully organized conference in such a beautiful place, and for putting us in this session of new issues. This is an issue that is probably as old as time, but it's also a new issue, because it's an issue that we're just beginning to seriously consider in studies in environmental epidemiology. So I am going to look at gender-based analysis of environment and health. And what I would like you to do, I'd like this to be sort of interactive. We all know about multitasking, particularly the women here. And what I would like you to do is to think about how what I'm talking about applies specifically to your own research. So this would be sort of like an interactive session where you ask questions of yourself and how you, in your research, be it field research, be it large data banks, be it institutional policy research, are considering the issues of gender and sex. Okay, I'd like to begin with two stories. One is of lead poisoning in the 1920s and 30s in the United States, and this is from Alice Hamilton. Alice Hamilton is the mother of modern occupational health. Bernardo Ramazzini is the father, a century earlier, but Alice Hamilton was probably the first woman. She was considered the mother of modern occupational health, and she did much work on lead poisoning. Studies showed that women workers had higher levels of lead compared to men, and the prevalent notion was that women workers were more susceptible to lead poisoning. And one sees this a lot, this idea of susceptibility. Women are more susceptible than men. However, what she did was she took into account job category and socioeconomic status, and she showed that when men and women were doing the same job, there was no difference in their blood lead levels. Indeed, women were working in the poorer paying jobs with higher exposures. And overall, they had higher lead levels as compared to men. So right away we see here a difference in not only the physical environment, the working environment, but also the social environment that was different even between men and women workers who were exposed to lead. The other story is a similar situation, more recent, a similar situation for pesticide poisonings. And this was a study from South Africa. And although official statistics in South Africa showed that more men suffered pesticide poisonings compared to women, enhanced surveillance, and that was door to door, and going to pharmacies, enhanced surveillance revealed that on the contrary, women had a higher prevalence of pesticide poisonings compared to men. Men and women's working conditions were different. Higher exposures in women, again, who did more seasonal work with high exposures and were likewise more exposed in the home. The other thing that made the difference was that women's approach to women were different, since the physicians did not think that women were exposed to pesticides. Their work was very often seasonal. A lot of problems were misdiagnosed because of the dominant belief that women were not exposed like men to pesticides, and they were classified as being hysterical or it was misdiagnosed. Just a similar situation in Dr. Bernda van Wendel's study, where women exposed to mancozeb had higher, those who were washing clothes in their home, both had higher levels of ETU, the metabolite for mancozeb. So what is sex and gender? What are we talking about? It seems strange that even now we're still looking at definitions, because for a long time we have sort of used the terms interchangeably when they're not. There's a lot of definitions for sex and gender, and the one that I personally prefer is, because I think it's the broadest, is the one from the Canadian Institutes for Health Research, where there is an institute for health, for gender and health. Sex refers to the set of biological attributes in humans and animals. It is primarily associated with physical and physiological features, including chromosomes, gene expression, hormone levels, function, etc. It is usually categorized as female or male, but there is a variation in the biological attributes that comprise sex and how these attributes are expressed. Gender, on the other hand, refers to the socially constructed roles, behaviors, expressions of identity of girls, women, boys, and men, how people perceive themselves and each other, how they act and interact. And this is, I think, the point that is important to make as well in the distribution of power and resources in society. Gender is usually conceptualized again as binary, girl, women, boy, man, yet there is considerable diversity in how individuals and groups understand, experience, and express it. So those are the definitions that we're using here. There have been milestones. One of, I'm sure all of you are aware of that when you do a review of the literature, and one of the things that came out some years ago about clinical research was that a lot of studies are done for a whole lot of reasons, either on male subjects or male animals, and are then generalized to the entire population. Now, this created a lot of problems with clinical trials, and from the 1990s, government guidelines began to include women in clinical research and evaluate sex differences. By the 1990s, some funding agencies required inclusion of both sexes or justification of why one or the other. And by the year 2000, there began to have guidelines for integration of concepts of gender and sex into health research. In Europe, there's Horizon 2020, which is the European Union Framework Program for Research and Innovation. And its objectives are to foster gender balance in research teams in order to close the gap in the participation of women, ensure gender balance in decision-making in order to reach the target of 40% of the underrepresented sex in panels and groups, and to integrate gender dimension in research and innovation content to help improve the scientific quality and societal relevance of the produced knowledge, technology, and/or innovation. And I'd like to stress the importance of the scientific quality. This is not just a program for gender equality, which of course is an important aspect. It is also a program for scientific quality. Because if there are differences that are not being taken into account, then this is certainly affecting the scientific quality. So what are the considerations of not examining gender and sex? You underestimate, and here we'll apply to environmental health, you underestimate the environmental health-related problems in one sex or the other, or both, because you're putting them both together. And I think there was a very good example of that when Dr. Betrazi presented the Seveso cardiovascular data. When both men and women were together, it was just just about significance level, but then when the sexes were separated, one saw that in both sexes there were problems, there were health cardiovascular problems that expressed themselves, that manifested themselves differently. And all of a sudden, the numbers changed. Health problems are then attributed to other causes such as susceptibility, hysteria, complaining, but there's also the cycle of ignorance. There's less research on the particular situation because it is not viewed as an environmentally related problem and thus not a research priority. And if it's not a research priority, then we're not going to fund it. So that thinking about that, it's a really vicious circle, because if one's not studying it, then it's not a priority, we don't know much about it, and if we don't know much about it, then we don't study it. And prevention strategies. There's a lot of emphasis in this conference, and rightfully so. Prevention strategies that target the source, the transmission, or the effects of environmental hazards do not necessarily address the entire population. So this is, let us look at it more closely with environmental health. We all know, I mean, we know this. We know this from the time that we begin distinguishing between mama and papa, is that there are gender and sex differences throughout the lifespan, through fetal growth, puberty, menopause, to the end, to the decline of our biological functions, where the differences become less. But gender are the experiences, infant and childhood experiences, adolescence, working and family life, retirement, and we know that these experiences are different for boys and girls and men and women, and yet we seldom, more and more, but I would even say seldom, certainly not enough, translate this into our research. Of course, the two are continually in interaction, and the contact with the environment is different. If you're doing different activities, if you have different work, different play activities, then the contact with the environment is different. And of course, depending upon the society in which we live, where gender roles are more or less defined, these differences can be greater or smaller. So what I'd like to do is just look at some of the issues that when one goes through from the sources of exposure to biomarkers of exposure, biomarkers of effect, health outcomes, and finally, social impact, which is not necessarily the same. Social impact will act both on health outcomes and on the sources of exposure. So sources of exposure. Looking over the lifetime, this is the average hours per week doing unpaid work and paid work by sex and age. And you can see that, and this comes from the US Census, you can see that overall men and women's time doing work, unpaid and paid work, is similar. But the breakdown is different. Men are doing overall more paid work over the lifetime, and as one you expect, it changes over the lifetime. Women are doing both paid and unpaid work. So that immediately changes what our relationship is to environmental factors. Where are we being exposed, and how are we being exposed? This is an interesting, I thought that this was an interesting illustration of it, because here we see gender-related exposure patterns. This is a study of passive smoking and mental distress in China. And if you just look at the prevalences of exposure to passive smoking, you can see that for men and women, it's similar. And then you can just go on and leave it like that. Or you can go on and look at it more closely. And then you will see that, interestingly, women are more exposed than men in terms of times per week. Now, why is this? You then look at the source of passive smoking, and women are more exposed in the home, and men are more exposed in the workplace. So that when we put these all together, we come up with a different pattern of exposure in men and women. And this pattern of exposure, which is similar to what we saw with the pesticide poisonings in South Africa. Men were working all the time in the fields. Women were exposed, doing seasonal work right behind where they were spraying. They would be taking out the sprouts. They would be weeding. No, it's not weeding. Taking out the sprouts. I'm not sure what the word is in English, but they would be taking out the sprouts behind the machine that was spraying. They're also spraying in homes. And in homes, there's very little ventilation for spraying. It's very different from agricultural workers. Very often, you will be spraying inside cupboards, inside cabinets, with very little ventilation. So that women's pesticide exposure, like in this case in China, their exposure to passive smoking can be higher than men's. One of the things is reporting in major databases. Very often, again, one limits oneself to the prevalence of men and women, and this is from the US and Haynes, where they report age, they report gender, report race and ethnicity. But that's all one knows about differences between boys and girls and men and women. The Canadian Health Measures Survey goes a step farther. They do present the data for males and females separately, stratified by age, so that one gets a better, one can get the profile of biomarkers of exposure in this case over the lifetime, rather than just what are the overall differences between men and women. I'm sure many of you who work with urinary metabolites know this. This is Dana Barr's work. Creatinine-adjusted urinary metabolites that are often used to assess exposures. There are sex-related differences and age and ethnicity-related differences. And here you see the data from the Canadian Health Measures Survey for urinary bisphenol A, and you can see that if you don't correct, as we say for creatinine, then it is the men who have higher levels, and if you do correct, it is the women that have higher levels because of differences in metabolism, which result in differences in creatinine levels. So which are we using? Dana Barr suggests, and I think that's what a lot of people are doing now, to include creatinine or urine density in regression models. I'd like to look a bit at manganese. One is because I study manganese a lot, and it's fascinating. It's fascinating because it's an essential element that when ingested in food is subject to homeostatic control, but when inhaled or in drinking water may be neurotoxic. Historically, manganese has been studied as an occupational hazard in male-dominated industries, foundries, battery manufacturing, mining. More recently, environmental exposures have been studied in communities exposed to manganese from industrial pollution, such as manganese alloy production plants, well water, which can be naturally or anthropogenically contaminated, manganese-based pesticides, such as mancozeb and maneb, or ceramic production, the black color in a lot of ceramics, when the vapors from the kilns can have high levels of manganese. So what do we know about manganese? This is from Ana Maria Mora's paper and where you see blood manganese concentrations during pregnancy. Golly, I thought and that it increases during pregnancy. What makes the difference here is, from the different studies, is external environmental exposure. However, when you look at fetal uptake of contaminants, you can see that boys, I compare here lead, organic mercury, and manganese. Lead is by diffusion. Organic mercury, we know, is uptake, and the ratio is about 1.7 of cord to maternal blood, whereas manganese, it's over 2, and it's different between boys and girls. This is from the NHANES requirements that vary with sex and age, and you can see that manganese requirements vary with sex and age, so that when one's thinking of using manganese as a biomarker of exposure, one needs to remember that it is an essential element that varies over time, whose requirements vary with age. Urinary manganese as well, this is from Dr. Berglund's paper. Urinary manganese, you can see that women excrete more manganese than men. Well, when I get to biomarkers of effect, and here I spent a lot of time, I spent weeks trying to figure out what to say here. I was going to present all these tables that show effects in girls, effects in boys, and as I was going over the literature, what I realized was that, interestingly, the findings are not always consistent from one study to the next when one stratifies boys and girls, men and women. It could be that exposure biomarkers don't represent the same thing. Covariables may not be the same. Health outcomes manifest differently, or social context may influence some of the outcomes. I included this because I just couldn't. I began looking at all of them, and not just these, but all studies in different areas in order to show that in your area, whatever area you're working in, it's there. It would have been too much. So here are some of the review articles, and I'd like to draw your attention to Jane Clafferty's article, which is a growing role for gender analysis in air pollution epidemiology. And those of you who are working in air pollution epidemiology, I would strongly suggest you read this. This will be available if you're interested. So let's get to the social impacts. One of the impacts that can be different, one of the impacts of toxics is on IQ. There's been a lot of studies, lead, manganese, the organochlorines, the OPs, and there's a sort of cycle. Mother's exposure, newborn is underweight, there's further exposure through breast milk, but there's also benefits through breast milk. Poverty and lack of knowledge, there's environmental exposure, children are playing on the ground. This leads to developmental delays, lack of energy, poor school performance, teenager to adult school dropout, poor jobs, and all of this in boys and men. Prenatal lead exposure is associated with a higher prevalence of antisocial, delinquent behavior, whereas this is not necessarily how it manifests itself in women. And in women, I think that one should be looking at, what about teenage? This often translates in girls as teenage pregnancies. So that even the social impacts on one or the other are not the same. And this is one that I find very moving. Menarche is occurring at a younger age. It's been associated with endocrine modifiers. Secondary sexual characteristics are appearing in much younger girls. And what does this mean? I mean, we can look at it, we measure things. But then I read this as I was preparing this, and this is from an interview of a young girl, and it's who does had precocious puberty, and it was like stressful, because I was sitting there and I was looking like a woman. Do you know what I'm saying? Looking like a woman, but inside I was so immature. I remember sitting in a guy's crib, that's an apartment, getting ready to smoke, him thinking like I'm 18, and I'm only 10 years old. And I didn't say much at the time because I was immature, dressing like I was, walking like I was. I didn't know how to make myself feel older. So the social impact of what we're measuring can likewise be different in girls, in boys, in men and women. Challenges. Gender stratifying of data is a good beginning, but do the initial questions adequately capture boys and girls, men and women's exposure situations? Are physiological differences considered in the choice of biomarkers of exposure and effects? Are the assumptions based on animal studies that used both sexes or just one? Are the health outcomes and their measures appropriate for both sexes? Do the social impact cover gender-related situations? Do the statistical techniques capture the complex interrelations between gender, sex, exposure, and health? And are the findings relevant to improving the health, well-being, and the environment of men and women and boys and girls? And these challenges are present as well for the new situations. Thank you. Oh, questions. Is there time for questions?
Thank you for your presentation. We have time for comments or questions. If there are, please. Any questions, comments? From upstairs, please.
Dear Harry.
Yeah. Thank you, Donna, for your nice presentation. Your gender difference in urinary manganese is not questionable, but I would like to know what is behind that difference. Is it just the correction for creatinine, or was it corrected for creatinine, or are it hormonal differences? Can you comment on that?
In the data that I showed, the variation over a lifetime was blood manganese, which varies over the lifetime. Probably one of the reasons is, Harry, you know, it's not a very good bioindicator of effect. Urine was, I believe, that's from Dr. Berglund's study, I believe that it was grams per liter. She sees the same thing if it's corrected for creatinine, is that the females will excrete more than males. The reason why I'm showing this was not really to talk about manganese as such, but to say that when there are differences, we need to be able to know them and know what they mean. And right now, for many of these things, we don't know what they mean, which is one of the reasons why I think there is inconsistent findings in the literature, is that if we knew more about these differences, we would be able to better understand the inconsistencies, which could then become more consistent.
Other questions?
Thank you.
Donna, I have a question to you. Thanks a lot for this very nice talk. A few policies are gender specific or sex specific in the sense pregnant women are supposed to omit certain exposures, and this is well known, but do you think ultimately we might need gender specific policy frameworks, or what do you think?
Well, I think that the framework, well, let's just firstly with respect to pregnancy. And there were very, very long debates. In Quebec, we have, for women workers, we have preventive leave for pregnant women. And women who are exposed to solvents can leave they're either given another job or they are get compensation. It's prior to maternity leave to be out. So ideally, working conditions, if we talk about working conditions, everybody should be able to do them safely. But until we get to this ideal world, there are measures in place to, well, the measures with respect to pregnancy are much more to protect the fetus than to protect the mother. I think that the idea of integrating gender into policy is to ensure that the policy, whatever policy it is, particularly health policies and prevention policies, cover the situation of both genders so that we think about it. I'll give another example is when we talk about climate change, we always have in mind the firefighters, the men who are working out in the field. It's very male dominated. But women who are working in what are called sweatshops in the garment industry throughout the world, where there's very little ventilation, as the temperature goes up, so does the temperature where they're working goes up. So that it's thinking about this, it's when we talk about climate change, not only showing pictures of the firefighters, but also of women's job and women having to go farther away to carry water, etc.
Okay, thank you very much. I think we can go on with the second presentation, please.